All right, in this second segment, I'm going to show you how we would solve for an unknown angle. And to be honest, the process is almost identical using the exact same formula. It's just where the unknown is. So again, we're going to go to our given triangle. So I'm working here on number 2. And the question is asking us to find the measure of angle B. And again, notice that the angle is written with a capital letter. So here is the capital B. So they are essentially asking us to find this angle right here. How many degrees is that angle? Okay. So again, I think it is probably best if we start off by listing all the things that we know about the triangle and or what we want to know about the triangle. So let's go through this. Okay, so if this is capital A, then across from that would be little a. So notice we don't know anything about capital A or little a. If this is capital C, then across from that would be lowercase c. And just like we said earlier, if this is capital B, then this would be lowercase b. So it seems like I mostly know information about B's and C's. So I know capital C is 104 degrees. I know lowercase c is 25. I know capital B, I want to know. So obviously I have to include that in the equation. And then lowercase b is 16. And I don't know anything about A, so I really can't use that. So when I'm choosing which two pieces of the law of sines I want to use, I can tell I need to use, let me get yellow. I can tell I'm definitely going to need C, and I'm definitely going to need B. So that's going to lead me to sine of capital B over little b is equal to sine of capital C over little c. And so now I'm going to replace what I know and what I don't know. So capital B, actually I shouldn't have erased that. I don't know what capital B is. So that's going to be my goal in this question, is to figure out the value of this variable right here. Okay. I do know the value of little b. That's going to be 16. I do know the value of capital C. That is 104. And I do know the value of little c. That is 25. So again, notice that I set up a proportion. I set up two fractions that are equal to each other. And one of the best methods to use when solving a proportion is what we call cross multiplying. So there's those two and these two. Okay, so if I do my proportion, I will get, so I'll do the, it doesn't matter, but I'll do the green first. So this is 25 sine B is equal to 16, this is the orange, times sine of 104 degrees. And again, my goal is to get B alone, so I need to get rid of the 25. So I'm going to do that by dividing by 25. Dividing by 25. And this is where Desmos will come in real handy. So let me go ahead and make my one here. Sorry, that looked kind of ugly. But now I don't need that. So let me go into Desmos, and I have to do 16 sine 104 over 25. So Desmos. So now I'm going to do 16 sine 104 divided by 25. And again, let me just check. I'm in degrees, so I'm good. So that would mean that I have, let me round to 3 decimals to be as precise as possible. So 0.621. So I'm going to go back to my notes, and this is going to be sine, this is going to be sine of B is equal to 0.621. Okay, now this takes us back to the very beginning of our trig unit where I introduced you to ways to solve for angles. So again, we said that capital letters are angles, so that's exactly what we want to know here. And the sine is currently in the way. So this is blocking my value of my angle. So how would I get rid of just sine by itself? How would I jump in and access the angle that is hidden, trapped inside of sine? Hopefully you remember our good friend sine inverse. Sine inverse. And that will undo it. Okay? So we can find angle B by writing sine inverse of 0.621. So I'm going to go to Desmos now and I'm going to do the inverse sine. So I'm going to go to a new line here. So I'm going to do, actually let me go to functions, sine inverse of 0.621. And if you notice, it says 38.39-ish. So 38.39. So angle B is about 38.39 degrees. Okay, I do want to pause for 1 second and expose you to something that you may run into in the future. And it's something, it's not really, it's just a different way of saying the same thing. So if you notice here, we're going to be relying on inverse sine and inverse cosine a lot. And up to this point, we've mostly called it inverse. But I also want you to be aware that there is an alternate way of expressing inverse. And so I also could have said, I could have written this exact same thing this way. I could have called it arc sine of 0.621. And I'm going to jump back into Desmos real quick, and I'm going to show you that if you put arc sine, is it a, no it's not, but if I put ARC sine, and then in the parentheses, I put 0.621, notice that it gives me the exact same thing. So this sine inverse and this sine inverse and arc sine have the exact same meaning. So just be aware of that because you could run into both notations, but they're the same meaning. Okay, so back to the notes. So this also gives me a B value of 38.39 degrees. Okay, so we just did 2 examples, one using the law of sines to solve for an unknown side length and using the law of sines to solve for an unknown angle length, and I introduced you to an alternate way of saying inverse, which is arc. So there's also arc cosine, arc tangent, etc., etc.